Okay, now let us continue hydraulic jump steering basin. So design a hydraulic jump steering basin for the maximum discharge of 25 meter cube per second per meter width of the spillway flowing over an overflow spillway with the spillway crest 50 meter above the downstream river bed level. So the river has a longitudinal slope of S naught 0.001 and Manning's roughness coefficient of N 0.028. And the rectangular steering basin has the same width with that of the spillway. So the same cross section rectangular, the spillway and the steering basin downstream of the spillway, the same cross section rectangular. So this is a discharge over the spillway, which is, I think, you can see this, I think. This is the discharge crust. So you may provide bucket downstream of the spillway and provide buckets. So once just should leap to the air just to dissipate the energy flow so that you can find other parameters. So let us see. Discharge intensity is given by Q, small q, capital Q over A. So this is a spillway crest cross section. So step one, determination of head and uniform flow depths. So you have effective head. So calculate effective head 5.055 you get. So once you get this value, the downstream river bed has uniform flow depths. After jumping, then it will attain uniform flow depths. After just this is the steering basin, then it will go to this downstream direction, which is uniform flow depths you have. It will attain after jumping. So I think this is a revision, I think. So let us see. Assuming the river width is wide channel, such that hydraulic radius approximately equal to normal flow depths. So from Manning's equation, you get this equation, which is important. Then 25 you insert instead of Q, then find Y naught. So Y naught is uniform flow depths. According to this equation, you get this value. Then determination of Froude number, step 3, step 2. So in step 2, just determination of Froude number. So and pre-jump depths Y1. So once you calculate Froude number, you can just check whether it is subcritical or supercritical. So specific energy, you have this equation, specific energy Y plus V square over 2G. So you have this specific energy, then you can calculate now V Q over area. Then Q means small q times width of the spillway. Area means B times Y. So B cancel Q over Y. So V means Q over Y. So you can substitute instead of V, Q over Y. So once you substitute, then you get this equation. So this V is a coefficient just to allow a coefficient, just a coefficient so that you can calculate appropriate dimension. So where V is 1 minus 0.0155 times P over H. So with respect to the spillway height and the head above the spillway, you have this equation which is phi. So you will allow. So you substitute here, then by try and error, you just substitute here, then Y1 will be 0.905 meter. So if you get Y1, then V means Q over Y1, then 27.62 meter per second. So next step will be Froude number you can calculate. So Froude number you can just insert in instead of V1 Q over Y1. So you can substitute this, then you get this value, which is 9.27, which is Froude number. You can see now this is just more than 1. So it is a supercritical flow. Now let us see the sequent depths. Step 3, determination of sequent depths, Y2. Y2 means just you can use this equation, then you can see this is spillway height and design head, then H1, Y1 before jump, then after jumping you will have Y2. So V1, V2 you can calculate. So this is hydraulic jump formation. So to dissipate the energy of the flow which is coming from the spillway crust, you will provide a steering basin, which is a basin which is just somewhat like this structure. So you may provide baffle block. This is baffle block to create staggering against the flow of water. and this is a chute block. Sometimes you may provide chute block again. So I think in our previous chapter already we have seen. So this is a stealing basin. So these are energy dissipators. So in the spillway, you may provide this bucket, solid bucket, as we have seen in the previous movie, or roller bucket, which is slotted roller bucket. This is solid. So when flow is coming here, then it will just jump like this to the air. So this is just at the foot of the spillway you can provide. But here, when the spillway just reaches the river bed, you can provide stealing basin. So stealing basin rather than bucket. So when it reaches this river region, you provide stealing basin like this. So determination of sequent depths, you just substitute y2, which is post jump. Post jump, you can calculate using this equation. So you get 11.42 meter. So from this result, sequent depths or post jump is very, very, very larger than normal flow depths. So hence the stealing basin is required. So you have to provide a stealing basin just somewhat deep here. You dug, then you provide stealing basin so that like this you provide, then energy will be dissipated circulating here, then it will go uniformly to this direction. So this is important. So stealing basin is required since y2 is very larger than uniform flow depths. So step 4, determination of basin depths. This is the depth of the basin. At what depth you go below the river bed level. So basin depths y prime, take safety coefficient sigma prime 1.2. Sigma prime actually it ranges between 1.1 up to 1.25. So basin depths y prime equal to sigma prime y2 minus y0. So you get this value. This is y prime. So this is basin depths. So for construction simplicity, you can take 7.5 meter. 7.5 meter is appropriate dimension for construction. So you can take 7.5. So take new datum at the basin bed level now. This is the basin depth you get 7.5. Then this is the new datum level. So from this new datum level, again, you proceed energy equation. So total energy is 50 plus 50 means P dimension plus 5.055, which is effective weight, then plus basin depths. You start from this new level. So again, you substitute again in this phi equation, P plus Y prime. Previously it was P over H. P plus Y prime, you get this value. So this is less than the previous value, so you can continue. Okay, so this is all about today's tutorial. Hopefully you liked the video. If you have any comment or doubt regarding this topic, please let me know and write down in the comment section below. I will definitely reply on it.